How do you 3D print with discarded plastic? How do you 3D print with trash, basically? It is a serious need, particularly in parts of the world that don't have the space to deal well with their discarded material. Better to make something useful out of it. I'm Peter Zelinski. This is a bonus episode of Manufacturing Unlimited, brought to you by ASTM International and by ICAM, the International Conference on Advanced Manufacturing, held every year. So we recently posted an episode on the ReCreateIt project, which is making consumer goods through 3D printing out of reclaimed material, entirely out of discarded plastic. But how does the 3D printer enable that? Well, I am at Re3D in Austin, Texas, the maker of the 3D printer that the ReCreateIt project uses. This is the Terabot X 3D printer from Re3D. It is a scaled up version of the Gigabot X that the ReCreateIt project uses. And here's how this 3D printer solves the engineering challenges of discarded waste material. If that's not your material choice, in a more typical 3D printer using filament, even using pellet, that material choice solves a lot of problems. That material choice is inherently consistent, consistent density, for example. Not the case with discarded plastic that is simply shredded into flake. Flake about 3 millimeters in size. And you can see the flake material starts here. It is simply poured into that funnel-shaped hopper up top. The main challenge of that material is low bulk density, the way all of that flake just randomly fits together, and inconsistent bulk density. So that has to be addressed. Inconsistent material can't deliver a consistent print. So here's how the printer design deals with that. The first station after the gravity feeding is this auger, 45 degrees, and it addresses that inconsistent pack density and low pack density. The auger compacts the material, compacts it into more consistent density, and pushes it into the extruder. The extruder is much more like an injection molding machine extruder than a typical extruder on a 3D printer. A 3D printer using filament material, able to benefit from the consistency of filament material, can use an extruder that is much simpler. But Re3D worked with the designer of extrusion nozzles for injection molding machines to develop an extruder that works well with this material. Here's the screw. Same screw is running inside of this extruder, and you can see it is segmented into different stations as the material becomes better and better prepared for 3D printing along the course of this screw. The auger pushes it into this first zone, which feeds the material. That's followed by a second zone in which the material is compressed. The density is made higher, more consistent. And then finally, here is this mixing zone. The material is stirred up, made, again, as consistent as it can possibly be. And at this area, this is where that material, which began as shredded, randomly packed flake, material that was easy to load into the machine, goes through this sequence of steps and finally is mixed together at the end of the screw to become material that is consistent enough for high value, highly engineered 3D prints.